Welcome to Surds Level 4, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move up to the next one, and you can find topic by topic playlists on the channel homepage. In problem 1, we're simplifying the square root of 75 over 15. Now to start, what we'd like to try and do is simplify the square root of 75. And to do this, we need to find two numbers that multiply to make 75, where one is a square number. And we can see on our square number list that 25 is a factor of 75, because 25 times 3 is 75. And this means that the square root of 75 can be rewritten as the square root of 25 times the square root of 3. And the square root of 25 is 5, so this becomes 5 root 3. So replacing the square root of 75 in our fraction with 5 root 3, we have 5 root 3 over 15. Now 5 and 15 can both be divided by 5, so we can simplify this further. So if we divide the numerator and denominator both by 5, this becomes, well, 5 divided by 5 is 1, so our numerator is just 1 root 3 or root 3, and 15 divided by 5 is 3. So root 3 over 3 is our final answer to problem 1. In problem 2, we're simplifying the square root of 20 divided by the square root of 5. Again here, we can start by looking at whether we can simplify the square root of 20 on the numerator. And we do this by looking for two numbers that multiply to make 20, where one is a square number. And 4 times 5 is 20, and 4 is a square number. So that means we can rewrite the square root of 20 as the square root of 4 times the square root of 5. And since the square root of 4 is 2, this becomes 2 root 5. So substituting root 20 with 2 root 5 in our fraction, we have 2 root 5 over root 5. And because we now have a square root of 5 on the numerator and the denominator, we can cancel those out and we're just left with 2. So 2 is our final answer to problem 2. In problem 3, we're rationalising and simplifying 7 over the square root of 11. Now to rationalise means to remove the surd from the denominator. And in this case, we can do this by multiplying the denominator, root 11, by itself. Because when we times a surd by itself, the square root part disappears. To keep the fraction equivalent, we need to do exactly the same on the numerator, so times by the square root of 11. Now looking at the numerator, 7 multiplied by the square root of 11 just gives us 7 root 11. And on the denominator, root 11 multiplied by root 11 just gives us 11. And since 7 and 11 have no common factors greater than 1, this fraction is simplified. So our final answer to problem 3 is 7 root 11 over 11. In problem 4, we're rationalising and simplifying 8 over 3 root 2. Again, to rationalise means that we need to remove the surd from the denominator, and we can do this in a very similar way to problem 3, where we can remove the square root from the root 2 by multiplying it by itself, because root 2 times root 2 gives us 2. We could also multiply by 3 root 2 if we wanted to, but that just makes things a little more complicated than they need to be. Now for multiplying the denominator by root 2, we have to do exactly the same on the numerator to keep the fraction equivalent. So looking at the numerator, 8 multiplied by root 2 just gives us 8 root 2. And on the denominator, we have 3 multiplied by root 2 times root 2, which is just 2. 3 times 2 is 6, so this becomes 8 root 2 over 6. And looking at the numerator and denominator, 8 and 6 can both be divided by 2. So we can simplify this further by dividing the top and bottom of the fraction by 2. 8 divided by 2 is 4, so this becomes 4 root 2. And 6 divided by 2 is 3, so this becomes 3. So 4 root 2 over 3 is our final answer to problem 4. In problem 5, we're rationalising and simplifying 2 root 63 plus root 28 all over root 6. Now to rationalise means that we need to remove the surd from the denominator, and so we could start, as we have done in the previous questions, by multiplying the denominator by itself, by root 6, and doing exactly the same on the numerator to keep the fraction equivalent. And although this approach will be absolutely fine, Because we've got quite large numbers in these surds here, it might be sensible to first try and simplify those individually. So that's where I'm going to start. So starting with the square root of 63, we want two numbers that multiply to make 63 where one is a square number. And 9 times 7 makes 63. So we can rewrite the square root of 63 as the square root of 9 times the square root of 7. And this gives us 3 root 7 because the square root of 9 is 3. Moving on to the square root of 28. 28 can be written as 4 times 7, and 4 is a square number. So we can rewrite this as the square root of 4 times the square root of 7. And because the square root of 4 is 2, this becomes 2 root 7. Now looking at the square root of 6, we can't multiply together two numbers to make 6 where one is a square number. So this means that we can't simplify this surd at the moment. So going back to our fraction, 2 root 63 becomes 2 multiplied by 3 root 7 plus the square root of 28 becomes 2 root 7, and on our denominator we just have root 6. Now we can simplify the numerator because 2 times 3 root 7 is 6 root 7, because 2 times 3 is 6. We have a plus 2 root 7 afterwards, and we still have our root 6 on the bottom. Now staying on the numerator, 6 root 7 plus 2 root 7 is just 8 root 7, because 6 plus 2 is 8. So you have 8 root 7 over root 6. Now this still needs to be rationalised because we still have a surd in the denominator. So we can remove the surd from the denominator by multiplying this by root 6, and to keep the fraction equivalent we need to do the same on the numerator. Now looking at the numerator, we have 8, and then root 7 times root 6 is the same as the square root of 7 times 6, and 7 times 6 is 42. So we have 8 times root 42, and on our denominator, root 6 times root 6 just gives us 6. Now we can simplify this fraction because 8 and 6 can both be divided by 2. So we can divide the top and bottom of the fraction by 2, and this gives us 4 root 42 divided by 6 divided by 2 is 3. Now it looks as though we should be able to simplify the square root of 42, but actually 42 can't be written as a product of two numbers where one is a square number. So this means that 4 root 42 over 3 is simplified, and this is our final answer to problem 5.